Hello, I am Mr. Mutisya and welcome to the mathematics session. In our today's session, we are going to look at parallel vectors. Vectors are said to be parallel if they are scalar multiples of each other. Vectors are said to be parallel if they are scalar multiples of each other. What does that one mean? Let's consider two vectors A and vector B. If we have these two vectors A and B, then if we have two vectors A and B, then vector A is parallel to vector B if vector A is a scalar multiple of vector B, or vector B is a scalar multiple of vector A. If we have two vectors A and B, then vector A is parallel to vector B if vector B is a scalar multiple of vector A, or you can say that if vector A is a scalar multiple of vector B. So this word brings out the real fact. This word brings out the real fact about parallel vectors. In this case, you can see that we have K here. We have K. In this case, K is a scalar. K is a scalar. K is a scalar. K is a scalar. Now, that's the law of parallel vectors. I want us to look at some examples and see how we find out whether vectors are parallel or not. So in this example, the question is state whether vector A is parallel to vector B. State whether vector A is parallel to vector B. So we know the fact that if these two vectors are parallel, then they must be scalar multiples of each other. Therefore, what we are going to do here, we are going to equate these two vectors including the scalar k. So we equate them including the scalar k. So this is what we are going to do. We are going to write the two vectors, vector A, which is 5, 3, and it should be equal to k, which is a scalar, vector B, k vector B, 25, 15, 25, 25, 15, like that. Then when we write it like that, we are going to equate 5 to 25k and equate 3 to 15k. That means that we are going to have two equations, of which in each we are going to solve for the value of k. So then we are going to have 5 equal to 25k, and then here solving for the value of k, this will simply imply that k will be equal to 1/5. Very interesting here that k is equal to 1/5. Now we are going to move on and then find the value of k by using the second equation, whereby we are going to have 3 being equated to 15k. So we are going to have the second equation here by taking 3 and equating it to 15k. And solving this equation, then you realize that the value of k here, the value of k will be equal to 1/5 as well. Value of k will be equal to 1/5 as well. So you realize that in both equations, then the value of k is 1/5. The value of k is 1/5. Therefore, now we can continue, we can move on and say that vector A, which is 5, 3. Vector A, which is 5, 3, is equivalent to 1 over 5 of vector B, which is 25, 15, like that. Therefore, we can also say that A is equal to 1 over 5 of vector B. 1 over 5 of vector B, or we can even say that, or we can say that 5A is equivalent to vector B. Very interesting there. We can say that 5A is equivalent to vector B, and in our conclusion, then we conclude that vector A is parallel to vector B. Vector A is parallel to vector B. That's what we were looking for, because we have found that B is a scalar multiple of vector A. B is a scalar multiple of vector A. And here, vector A is a scalar multiple of vector B. Therefore, the two vectors A and B are parallel. Very correct. Let's look at another example. Here. Here is another example. In this example, the question is, state whether vector A and B are parallel. State if vectors A and B are parallel. So we follow the same steps. The first step, we equate the two vectors including the scalar k. So we are going to write the two vectors, vector A, which is negative 4, 2, 1, negative 4, 2, 1, equal to k, vector B, which is 12, negative 6, negative 3. K negative, that is K 12, negative 6, negative 3. Then we are going to form three equations here, and in each equation we'll be solving for the value of K. So you realize that when you take 12, divide by 4, you are going to get 3. If you also take that, you are going to get negative 3. If you take negative 6 divided by 2, the value of K will be negative 3 also. As well, if you take negative 3 divided by 1, that simply means that the value of K will be also negative 3. Now, let's do this one in an equation, but then the value of K here will be negative 1 over 3. But either of them is good with us. Let's do it. So we're going to form three equations here. Negative 4 should be equal to 12k. Negative 4 should be equal to 12k, which simply implies that k is equal to negative 1 over 3. Good. Now let's look at another equation here. From another equation, 2 should be equal to negative 6k. 2 should be equal to negative 6k, which simply implies that k is again equal to negative 1 over 3. K is equal to negative k is equal to negative, sorry here, k here is equal, k is equal to negative 1 over 3. K is equal to negative 1 over 3. Again, we form another equation. The last one. 1 is equal to negative 3k. And also, you realize that this one will also mean that the value of k is also equal to negative 1 over 3. Negative 1 over 3. Very interesting. We have a very interesting part here, whereby the value of k here is the same throughout. The value of k is the same throughout. Now, this now takes us to the next step. This takes us to the next step, proving whether these two vectors are parallel or not. Therefore, we are going now to write our two vectors a and b, now with the constant, with the realistic realistic scalar k. So our vector a, which is negative 4 to 1, negative 4 to 1 is equal to k, which is negative 1 over 3 of vector b, which is 12, negative 6, and negative 3. Very interesting. And negative 3. Let's move something here. And negative 3. That simply means that vector a, vector a is equivalent to 1 to negative 1 over 3. It's equivalent to negative 1 over 3 of vector b, or vector a, or negative 3 vector a is equal to vector b, and now this one simply proves that the two vectors a and b, are parallel, since they are scalar multiples of each other. Therefore vector a is parallel to vector b. Vector a is parallel to vector b. That is very interesting. And that one is very correct. Now let's look at our example number 3, which say that given that vectors a and vector b are parallel, find the values of x and y. Given the vectors a and b are parallel, find the value of x and y. So here, let us look at how we can find values of unknowns in vectors which are parallel. We know that for any parallel vectors, each is a scalar multiple of each other, and you realize that in this case we have a complete coordinate here because of 4 and negative 16. We have a complete coordinate over there. Therefore, this coordinate is going to help us in, first of all, finding the value of k. So we know that if these two vectors are parallel, then a is equal to kb. That is, b is equal to a scalar multiple of a, and A is a scalar multiple of B, like that. We know that. Therefore, we are going to equate 4. We're going to take 4 and equate it to 16k to negative 16k, which in this case will simply mean that k is equal to negative 1 over 4. You simply mean that k is equal to negative 1 over 4. That is our scalar. So now we're going to form two more equations for y and negative 12k, and another one for negative 2 and kx or xk, so that now we are able to find the values of x and y. So let's find the value of y first. We're going to find the value of y first. So y should be equal to negative 12k. Y should be equal to negative 12k. That means that y should be equal to negative 12 times negative 1 over 4. Now it looks better, times negative 1 over 4. Therefore, here these factors here, this one is a factor of 12, and 12 is a multiple of 4. So 4 and 12 can cancel each other, so that we have negative 3 there, and we have a negative 1 here. So it will mean that y is equal to negative 3 times negative 1, which will give us 3. Also, again, we can find the value of x now that we already have the value of y. Now that we have the value of y there, we can find the value of x. So we are going to form another equation. Negative 2 should be equal to xk. Negative 2 should be equal to xk. Remember, now we don't know the value of x, but we know the value of k. So we are going to have negative 2 equal to xk, whereby k is negative 1 over 4, but we don't know the value of x. So we are going to have negative 2 equal to negative 1 over 4 x. That will simply mean that x here will be equal to negative 2 times negative 4 over 1 times negative 4 over 1, which will simply mean that the value of x is equal to 8. The value of x is equal to 8. That simply means that the value of x is equal to 8, like that. So we have our answer now. Now we have our answer that x is equal to 8 and y is equal to 3. And in this case, then we have our answers right. Thank you for watching my video. You can subscribe for more videos and more tutorials on the mathematics section.